all. Again, if you are looking to do the test retake for topic 7 target 3 project, here is the next video. It is what was part 2 of the project. So again, it will be part of what's on the test. It addresses numerical data. So things that you'll be asked to do in this section would be to create a dot plot for the numbers, histogram, box and whisker plot, and then give some analysis on that information. So here is the problem. Again, not exactly the same as in your practice assignment, but it should help you figure that out. So it says that the high temperature of 10 days in a row in January are listed below, and I added that they're in degrees Fahrenheit, so I didn't have to write it sometimes. So here is the list of numbers, and I know there's 10 because it says 10 days. And the first thing I'm going to do before I do anything else, it doesn't ask me to do it, but you need to know that you should do it, which is list the numbers in numerical order. And that way we will actually be able to organize them a little bit more easily. So, last number is 35, and then 39, and then 40, and then I believe 42 and 43. And then, ooh, it looks like we have two 46s, two 49s, and then this really random one, which is 73. So pretty high compared to the rest of the numbers. Let's just count these real quick. Okay, great. And so now we know that of these 10 days that the coldest was a high of 35 and that the warmest was a high of 73 degrees. Okay, so the way I want you to do a dot plot and histogram is actually kind of put those two things together. And you can do them separately, but it's honestly just a lot easier to do them as one. And as long as you do it clearly, then I won't have a problem. But please don't try and get overly complicated. So we're going to do the dot plot and together because they actually build really nicely together. And what I want you to do is make sure that you are, again, doing things in correct scale. Okay, so preferably on graph paper. When you are given the test, the retake, you will have graph paper. So because I'm going to do the dot plot with the top plot, I want to give myself some room for those histogram bars. And we'll go ahead and do a horizontal line here. And this is going to be my dot plot. And what we want to do is, I don't want to start at 0 because my lowest number is 35. So I'm actually going to kind of start with a broken graph symbol, which means I don't have to start at 0. I can start at 35 and I need to go out to 73. So that's a distance of just under 40. So I need to figure out how I want to scale this because you're not just listing the numbers and then doing dots of them. You need to show a scale because there is a numerical relationship here that the distance between 35 and 39 is not the same as the distance from 39 to 40. Whereas when you look at categories, the categories can be evenly spaced because they're just all separate entities. So here, if I do 2, will I be able to get a 40? So here we do 2, 4, 6, 10, 40. So I can scale by 2s. It looks like that should work out just fine. So normally I would prefer to start right on 35, but it's a little bit easier for me to work with even numbers. So I'm going to go ahead and start with 34. So this one would be 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74. So I made my line a little long. That's okay. Um, and there you have it. We've got at least 35 on this end and at least up to 73 on this end. Okay, so what these represent, remember, is the high temperature in January of the days, of 10 days. And so we're going to write high temp spelling temperature in January, and that's acceptable abbreviation for January. And then again, because it is in degrees Fahrenheit, I want to make sure that I include that um, that unit, okay, so that people know. Otherwise, you'd have to write it after every number, and you don't want to do that. Okay, so here is how a dot plot is different for numerical data versus categorical data. So in categorical data, you just kind of stack the dots upward. Here, the only time you'll stack them vertically is if there is a repeat. Otherwise, you're kind of just plotting them on a number line. And what that does is it tells us how scattered the numbers are. So a dot plot for categorical data shows you how many in each category. Here, this tells us how spread out it is. So I'm just going to go ahead and plot these right on the number line, again, unless I get a repeat, and then I will put a dot right above. So here's 39, 40, 42, 43, 46, and then 46 is a repeat. So I'm going to put one above it because there is actually two there, and you want to make sure that we know there's two there. And then 49, and then again 49 has a repeat, and then we have this crazy random one of 73 right out there. And if we count these, there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Great. Okay, so this tells us that this was like one wacky hot day, quote unquote, hot in January, and then these are really relatively close together. Now, what I've said in the project and again on the practice, and it will be said a third time on this retake, is that I want at least 5 bars. What that means is that your histogram needs to have at least 5 bars. Now, you do not write under the histogram bars like 34-38, okay? Doing it on the number line tells us that for us. We don't actually have to do it. So I want there to be at least 10 bars. So this will be 1 bar for sure because it's way, way out here. So that means I kind of need 4 bars here. So it looks like actually if I go from 34 to 38, 38 to 42, 42 to 46, and 46 to 50, that's 4, and then that'll be my 5th bar. The thing you want to make sure though is that ones that are right on my transition, for example, 42 is going to be a transition and 56 is going to be a transition. You can't include those dots on both sides. So what I'm going to do is the start of the bar will include the dots in that bar. It ends on the end of the bar, it will be included in the next one. So to start doing this, it doesn't look like we're going to have very high bars. So luckily we don't need to make this very tall. So we need this y-axis here, and I'm pretty sure I'm going to go by 1, 2, 3, we'll add 0 in there, 4, 5, 6. And what this represents is this is number of days that are in that category. Number of days. So if it's is 3 high, we know that there were 3 bars. And I'm sorry, I didn't want to rotate my paper on the video, but number of days. So again, notice just like a bar graph, we have our X and Y axes. They're spaced consistently. And in addition to that, we have labels. So as I said, one will start at 34 and end at 38. So here from 34 to 38, there's none on the transitions, which is great, and there's just one dot in between. So that's going to have a bar height of 1. So from 34 to 38, of 1. Don't worry, I have my handy dandy line out. If you don't, just try and erase it. Hopefully that'll work since it'll be on the computer. So there's only one. Now here from 38 to 42, remember these all have to be of equal distances. So, excuse me, from here to here, there is one on the transition, 42. So remember, we're only including ones that start on the transition bar, but not the ones that end on it. So I'm actually only going to include these 2 dots, and that 42 will be included in the next one. So that means my next bar is too high because it only includes those 2 dots. This dot will go into the next section from 42 to 46. And if you look at that, again, these ones are on the end of the bar, the exact end. So they will again be bumped into the next section. The way I kind of did this in my I said, okay, you include these dots, and then I put a bar and it stopped right at 38. In the next section, you stop right at 42. When 42 include those, and then stop right there. So again, everything looks uniform. It's all uniform in the same way it's spread out. So again, we only include these 2. And so notice you can definitely still see my dots. This is what I meant about keeping it organized so that I'm able to tell what your dot plot is. So if you're gonna shade them in, shade in lightly so that I do know where your dots are. Because if it covers them up and I can't see them, then defeats the point, right? Okay, so on this bar here, we want to go from 46 to 50. Well, that means everything from 46 on it and all the way to 50. Well, that includes these 2 dots and those 2 dots. So that's 4. So I'm going to hide There we go. And now I even have to continue my intervals even though there's nothing there until I get to the correct interval, because what I don't want to do is each bar, whether the bar is 0 or not, needs to be the same width. So real quick, I'm just going to measure out what 70 to 74. So in this section. Great. So now there is my box or my histogram. And I realized I wrote Box and Whisker Plot, and I have been talking about a histogram, and that makes me feel real bad. So you can also stack a dot plot in a Box and Whisker Plot, but I meant histogram. I'm so sorry. So that's our histogram. Now notice our histogram, the bars do touch, and that's because unlike the categories that are completely separate in categorical data, in numerical data, right where one bar left leaves off, the very next number is included into the next bar. So that's why they have to touch each other, because right when this bar ends, the next dot would be included in that one. So they actually do incorporate it. And the reason there seems to be a gap here is because all the bars, which are represented by these kind of things down here, would have indeed been 0. So there actually isn't actually any gaps. Okay, so that's histogram. Okay, so sorry about that, guys. Histogram and Dotplot. Okay, so now we're going to move on to the Box and Whisker Plot. So the Box and Whisker Plot needs some data points to do that. So one of the great things about writing this numerical order is that we can then use it to find those summary numbers. So you need the max and the min, which oh my gosh, I keep messing this up. Apparently. No, I'm nervous. This one. This one. And hopefully you can still see that that is a 73. Okay. So now we also need the median. The median is the exact middle, but I'm going to tell you right now, since there's 10 pieces of data, I know that there's going to be no exact middle number. It's going to be halfway between two different numbers. So here I have my outer two, and then the two middle numbers here means my median is halfway between 43 and 46. So the way you get that is you add them together and divide by 2. So when we add 43 to 46, and I'll show it for you. Divided by 2, and that ends up being 44.5. And there's your median, 44, oops, 0.5. Great. Now, notice that my median fell between these two numbers, so that means that the top half is 5 data points and the bottom half is 5 data points. So then we find the middle of those, or the median of those, you could say, and those are your upper quartile and your lower quartile. So if I go to the lower half of the data and I find the exact middle, so there's 5 numbers here, so we go 1, 2, and you get this one, and this is your lower quartile. And what that means is essentially it splits your first quarter. So your bottom quarter is these 2 data points because there's 2, and then your second lowest quarter are those 2 data points, and then we'll have the same thing up here. We'll work our way in. Ends up being 49, and that is your upper quartile. So it breaks it into quarters. So from the min to the lower quartile is 2 data points. From the lower quartile to the median is 2. From the median to the upper quartile is 2. And from the median to the max is 2. Okay. So there are our 5 number summary. So for the okay, we again want to have a number line because it needs to be evenly spaced out. Okay. Now, I know I saw some that were like this wide. You need to spread that out, okay? We need to see what's happening. So I'm gonna go ahead and grab my ruler. I'm not measuring anything. And I am going to let me zoom out just a little bit for you. Does that work? Okay, sweet. And again, because this is uh, related to a problem, I do again want temperatures in January. Obviously, not all of January days, and again in degrees Fahrenheit. And I'm kind of wondering now, because I have more space, can I go by ones and fit everything in? So if I started at 35, let me check real quick. 35, no, no, I will not be making it. So we again should go by twos, and that should get us there. So again, it was only spread out like this, so I'm just gonna kind of do this kind of thing here. And here's 34, and I'll just bring the number line out. So 32, 30, 28, 26, 24, 22. Okay, and that would be 20. And then I can go up the other way like I did before, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84. All right, so there's my number line. And again, because this is going to show us how spread out our data is. What I want to do is find all of those 5 points, my lower quartile, my median, my upper quartile, and my max, and space them out on the number line exactly where they're supposed to go. So my min, let's see if I can get this in here too. Ooh, I can. My min is 35, so I'm going to go to 35. I'm not going to put it on the number line. I'm going to go ahead and go up and put a dot and a vertical line. Okay, so there's my min, and I always like to label. And then my lower quartile is 40, so I end up not being far away, and it's not in a line. And I'm just going to do a Q for lower quartile, and then 44.5. So here is actually 44, and it's only going to be a little bit in there, not even halfway. It's like a quarter of the way. 44.5. And that's my median. I'm going to abbreviate to MED. Then 49 right here, upper quartile. And then again, our really crazy high one of 73 up here. Okay, so now this is where the box and the whisker come in. So the middle ones, those make the box, and then from the lower quartile to my min is 1 whisker, and then from my upper quartile is the other. So remember, each of these sections, these 4 sections, contain the same number of days, right? 2 days on this whisker, 2 days in this box, 2 days in this box, and 2 days out here. The difference is how spread out they are. These are all relatively the same spread, right? These ones are approximately the same distance in temperature as those two. But here, this distance is really crazy, which means that the spread between those 2 days must be really big. Okay, so this is my box and whisker plot. And using these things, I am going to do some analysis. So my analysis has to do with answering questions and making conclusions about my data. So for example, an analysis question. So a good analysis question is just to say, like, what was the average temperature for a day, or the average high temperature? So the average high temperature, and what everyone now have to do is go and find the mean, where they have to add them all up and divide by the number of numbers. But average is just a blanket term meaning measure of central tendency. And you know what one measure of central tendency is? It is mean, but another one is median. Why would I bother going and finding the mean when I already know the median? So if I look up there, the median, or even way, way up here, the median is 44.5. So I can just say that the median high temperature was 44.5 degrees Fahrenheit. And I want to at unit in there because now I'm talking about in context. So average does not always mean mean. If I want you to find the mean, I'll ask for it. But if I say average, then you can technically use mean or median. Now, another good question that we can ask you to analyze is the data consistent and how do you know? So it can be consistent or inconsistent. And then are there any outliers and how do you know that? So let's first start with consistency. So is my data consistent or inconsistent? So consistency has to do with the interquartile range, how close the upper quartile and lower quartile are. So it doesn't have to do with the whole thing because sometimes you do have outliers, but then the rest of the data is consistent. So go back and think up here based on our dot plot. Yes, this one is crazy out here. So if I found the range, it would be huge. But look at most of my data points. 9 out of 10 data points are from 35 to 50. Those are pretty dang close together. So my data is consistent because, yep, not a lie, because the IQR range is small. And if I wanted to, I could do my upper quartile minus my lower quartile, which would be upper quartile minus is 49 minus 40 equals 9. And I could put in here and put because that means that my interquartile range only has a distance of 9 degrees apart, which is not very big. Okay, so it is pretty consistent. Now, if that interquartile range is huge, then it probably wouldn't be very consistent. There'd be a lot of variation in our data. But the last question is there an outlier? And how do I know? And as I've been pointing out this whole time, yes, there is an outlier. And the reason I know is boxes are actually pretty consistent in size and how far they're spread out from left to right. But this whisker really long, which you could talk about skew if you wanted. This would be skewed to the right. You could say the right whisker is very large. Okay. Now, if both sides were pretty large, you might have one on both sides, and if it's evenly spread out, then you probably don't have an outlier. So if you notice again that one side is particularly stretched out, then that's the cue that there's an outlier. Again, you can kind of see that because if you think about it up here on our dot plot, if we again were to remove this, all of my data becomes super close together. This box and whisker plot would actually end here at 49. So yeah, there's definitely an outlier because of that very long whisker. Okay, so there you have it on numerical data. Again, I apologize for my flub up on saying box and whisker plot with histogram, but just a quick review. You want to take your numerical data and put it in order from least to greatest because that will help you with your information. So your dot plot is incorporated into your histogram by starting with a number line and placing the dots along the number line. And that number line needs to be consistent. Don't just list the numbers that you see up above. The only time you add vertical dots is if you have the exact repeat of a number. Okay, and notice again, I have a label for that. And then the histogram, you break it into sections, right? And notice I didn't just do one bar for every point or location I had. You create chunks, and the chunks, you have to have at least 5 of them. And you need to determine where does it start and where does it stop. So I said that the number it starts on, if there's dots there, it's included in the bar. And then where the bar ends, if there's dots there, I didn't include them. Because again, if you add up the height of the bars, you should get that 10 because there were 10 numbers. And I added a vertical scale, again, that is consistent and evenly spaced, and I labeled it number of days. Okay. Then I did a box and whisker plot, which you need the 5-number summary for. So I found the min and the max, the median, which is exactly halfway. And since it was between 2 numbers, I added them up and divided by 2. And then once you have it split in half, you look at the bottom half and find the middle, and that's the lower quartile. And then you take the upper half and find the middle, and that's the upper quartile. Sorry, lower quartile, upper quartile. And then you are ready to make a box and whisker plot. The box goes from the upper quartile to the lower quartile. The whiskers go from the max to the min, and then you can analyze. Remember, average just means central tendency. It doesn't necessarily mean mean. So I used the median, and you're allowed to do that too. You already found it. Consistency has to do with IQR, the interquartile range. If you have a small interquartile range, it's consistent. If you have a large one, it's inconsistent. And lastly, are either of your whiskers really long compared to the rest of the data? If so, then yes, you have an outlier. If not, then no, you don't. All right. I hope that helps. I know it was a long video, but good luck.